The same whiteboard.
It is. It's just placed up on the.
All right, today we are looking at numerical variables. And what we would do when we were looking at associations between those.
I'm not upset that you're here. I'm just
All right. So for associations between numerical variables is where we use a scatter plot. All right, scatter plot. So we have we'll have a table, and I'll write up the table, and then we'll use that table to illustrate the things with a scatter plot. So the table below.
Is this part of the bivariate data?
This is part of the bivariate data, yes. Because there's still two variables, both of them this time are numerical. So the table below shows hours worked. So it's one of our variables against and percentage of population going to university for 9 countries. All right. So we would have 2 rows, could be 2 columns, in this case it's rows. The top row there is our percentage going of the population going to university. And the second row is the hours worked. The 9 countries, where that comes in is that we have 9 pieces of data. So each of these pairs of things is for one of the countries. So we need 9 of them. Like that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Not right now, you can't.
And we then get
Is
some.
it 2 by 9?
Well, there's 10 including this, but yeah, 2. Alright, so I'll give you a minute to get that down. And then we'll look at what we need to do. Beautiful.
like hours worked before university?
I'm assuming
Yeah, as in
that it means the hour used. If you've been to university or not, once you then get a job, how many hours per week do you work? I'm assuming that that's what they mean. Because that's all, this is kind of all the information, where I got this example from, this is all the information. So I'm assuming that percentage of the population that goes to uni and then after they've left uni and got jobs or whatever, then the average working hours for the population in that particular country. That's what I'm assuming is what it means.
yeah, because if you look at it, the ones that have really high working hours then have a low percentage of going to uni, so if you think about like India in that way, working all the time.
So yeah, maybe you've got lower paying jobs, so you need to work longer. Like
Yeah. Just trying to justify my head.
all right. So when we get a table, it is usual. It is usual that our explanatory variable, our EV, would be the first row or the first column. So EV is in the first row. All right. Or the first column, if it's in column form, if it's columns rather than rows. And then, of course, if that's the explanatory variable, this is the response variable then, in the second row.
Wait, so is it row or column?
Right, this is our percentage of population going to university would be our explanatory variable, and our response is hours worked. So how does the percentage of the population going to university affect the hours that they work later in life? So the RV, the second. All right, so in this case, percentage of the population going to university is the explanatory variable, and hours worked is the response variable. So when we construct a scatter plot, we need to do it in a particular way. And when we do that, our explanatory variable, the EV, goes on the horizontal axis and the RV on the vertical axis. So in brackets there, the x-axis if you like, and then the RV on the other one, of course. So in this particular case, we're going to have the percentage of our population. Oops, poll pop. Going to uni, and on here we're going to have our hours worked. All right. So I've got this handout that I will give you. Now, using your calculator, draw scatter plots. And then I'll put you through how we do that.
No. Thank you.
Are we gonna draw a big one or just a little?
Yeah, we're going to draw a big one.
So do I need to draw the little one?
You can draw the little one,
Oh,
just but we're going to draw the big one on the calculator.
Not too bad,
All right. So when we want to draw these using our calculator, we want the statistics menu, and you go onto that, and some lists will come up. Now I've already done this before, and so when we do our entering here, we want to put in list 1, we want to put our EV, and in list 2 we want to put our RV. Alright, that's just going to save us any hassles. Technically you don't have to put them in that order, however the way the calculator's default settings are, it'll make your life easier if you always put your explanatory variable in list 1 and your response variable in list 2. So those percentage going to university and hours worked are those that are there. So once you've got all of that, we need to tell the calculator what we want it to do, and we want it to draw a graph. And so we use this icon here to tell it what sort of graph we want it to do. So when I do that, so automatically what comes up is that you can draw 9 different graphs all at once if you like. So when I first come up, tab number 1's there, it's by default switched on. All the others are by default switched off. Our X list, so remember our X is our RV, and that's list 1.
you want to text them?
Oh, sorry, X list is our EV, not our RV. And that's list 1, which...
Wait, is it on or off? We'll keep it on.
Keep it on.
Yes.
All right, so in list 1, that's what I said, you know, you're better off if you do EV in list 1, RV in list 2, because the default settings is that. The Y, list 2, the Y, which is our RV, was already in list 2. So we already know. So if there's nothing else for us to do then, because that's our default. So now we've told the calculator what we want it to graph for us. Now we're going to tell it to graph it. And so that's where this icon here comes in. You click on that, and this is what you get.
So I put all the numbers in?
You can do that. Practice, yeah. So you can see here, then the calculator draws a graph for us. And here's our axes, and then we've got a whole bunch of the points, the 9. So each point is a particular country, where percentage of that country went to university and the hours that they worked. I don't think the scale's not quite right here, but we're looking for some sort of association, and it would certainly from this would appear that the higher percentage of people going to university work a little bit less hours from that. And reasons for that, there could be many reasons for that. But that certainly, from what's here, it certainly looks to be the case.
So is that what we would write for our conclusion, that the scatter plot shows an association between
Yep.
hours worked and that it's less hours?
So the higher the percentage of the population in a country that goes to university tend to work less hours. That's the kind of thing we would write. Which then leads us to the next bit. Interpreting the scatter plots.
Why? Is that what it's supposed to be?
I won't start the next bit. So has anyone not been able to get that on their calculator? No one's saying me. So.
Your shirt is very snazzy today.
Thank you. I've been getting lots of compliments about my shirt today.
He said he's only wearing it because Sue's at a physics convention and hated him for not matching.
I love it. I think it's great.
My wife doesn't like it, particularly when I wear checked shorts with this.
Did she watch your YouTube channel?
She even dislikes that even more.
Oh, double whammy.
Yep.
This
All
is where
right.
you look at the camera and say, hi, Sue.
All right, so interpreting. How are we going to interpret? So I've already get rid of Kobe Bryant. Interpreting scatter plots. All right, so when we're looking at scatter plots, there's a few things that we're interested in. All right, one of those. Is the direction. So as we're going from left to right, because we read left to right here in this country, so as we move left to right, what happens, and in this case with this particular one, as we move left to right, looks like we go down. And so that direction here would be described as negative, so you can have either a positive something like that, or a negative. Something like that. All right, so there's a negative association. So as the percentage population going to uni increases, hours worked decreases. So that's one of the things. One of the other things that you would look at is any outliers. And in this particular one here, they're really, this one you go, well, is it really far enough away to be an outlier? You probably need a better than by eye, but certainly if you had something that was, say, up so there, for example, you go, yeah, well, that's an outlier. So it can be a little bit subjective. So something that they're certainly way away from all of this stuff would be an outlier. So if there's any outliers, so here's a little graphic thing for that. Alright, so it needs to be quite obvious with the outlier. We all got that? Can we rub this side off? Yes, no, maybe. All right, the next thing we would look at is what's we call the form. So basically, the form is it linear. So that one there is kind of, could get a bit of a straight line and put a bit of a straight line through here. It's kind of linear. Or non-linear. So a non-linear one might something like that. So this particular one, curves. But we just use the words linear and non-linear. Don't worry about too much at this point in time of what the curves might be. All right. So this particular one that we've got here with the over here, probably not super clear because you could go, okay, well I could put a straight line through there, but then I could curve it round like that as well. So neither one of those necessarily looks any better than the other, so we have to do some more investigations on that one. All right, so hopefully most of the stuff will be very obvious as to whether it's non-linear. All right, the last thing that we look at is the strength. So if we've got something that's linear,
Is this the last one?
this is the last one.
So you should exit this.
So the strength is kind of how close to that straight line this is. So this stuff here is pretty close, so that's pretty strong. Over here, if I look at the blue one, let's get rid of those red. Get rid of those red ones. So yeah, not too bad, but scattered around a bit more. So you know they sort of could be moderate, and then if we've got a few more, then it'd be less so. Now, so we can use something that strong, moderate, weak. And the problem with those kind of terms is that these terms are subjective. Alright, I'm on this here, yeah, everyone's probably going to say that's strong, but once you start to get things spread out a little bit, it's subjective about when does it stop being strong and start being moderate, when does it stop being moderate and be weak. Alright, so they're a bit more subjective. Now there's another measure that we're going to use. It's called the Pearson's, because Pearson made it up. Pearson's correlation coefficient. Commonly known as the R value. And the good thing about the Pearson's correlation coefficient is that our calculator will work it out for us. But the key thing for you guys to remember.
Wait, what does that say?
Which one? R value, full stop. Our calculator will work this out for us. So it's a number. Pearson's correlation coefficient's a number. Key thing out of this, or two key things is this. Pearson's correlation coefficient and the R value. Happens every year that we get down the track a little bit. And someone will read a question and ask about Pearson's correlation coefficient, and you go, oh, question. They ask, what is it? And I say, oh, it's just the R. So those two things are the same. All right. So what I've got's another. I've got this document. This one here, and I'll give you this, and this should go in your notes. Found reference.
He's just not written anything.
Yeah, sure.
What is it wrong?
I love it. This is fantastic.
Thank you. Should have made it rainbow, like hot pink. We talked about this.
Hot pink.
Even though it's spice the notes up there.
And you talk about
I
hot
love
pink.
it.
No, I just said because Miss Stewart was doing a model.
Yeah, she
Hot
was.
pink.
So hot pink. You did.
What are the things?
The pipe thing.
Pipe cleaners,
Oh,
hot
yeah,
pink
yeah.
pipe cleaners. Oh, that's what I could have done. Hot pink pipe cleaners for the
Yeah.
shapes. I could have got my hot pink
Next time.
next time. All right, so this document here, stick it in your bound reference, gives you a bit of an indication of, what's strong, what's weak, what's no relationship. So description up the top, and down the bottom is these R values, Pearson's correlation coefficients. So these first two, let me scroll that document down. All right, so for Pearson, so I said the Pearson's correlation coefficient was a number, and so when you look at these first two here, R equals 1 and R equals minus 1, these two are the two limits. So R equals 1 is the biggest it is, and minus 1 is the smallest. So it's kind of like, for R equals 1, it's perfect positive straight line, and for R negative 1 it's a perfect negative. And so these others are kind of in between. So 0.9, for example, is negative, spread out a little bit. All right. R equals 0 is this one here, it's just all over the place. All right. So it kind of gives you a bit of an indication of what those graphs might look like. But as I said, if we've got a calculator, our calculator will do it for us. Now, unfortunately, Pearson's correlation coefficient is not always perfect because it relies on some things. So first of all, it relies on that our two variables here are numerical. So they have to be numbers. These variables have to be numbers. The next thing it relies on is that the association is linear. All right, so Pearson's looking for a linear. So over here I've got a linear. Pearson will work out all right. Here this one's a non-linear. Pearson's not going to work out all that well because the Pearson's assuming that a straight line goes through this somewhere or other. All right, and so you've got a lot of scattering this side, a lot of scattering that side, and so it doesn't work out that well. The other thing that Pearson relies on is that you don't have any outliers. So if I've got an outlier up here somewhere, then that piece of data is going to affect my Pearson's correlation coefficient. So as you can see, this pretty good straight line here, and so you'd expect a Pearson's correlation coefficient of somewhere like 1, close to 1, but just having this one outlier here is going to put that out of whack. So there's some assumptions. So we will write those down because it is possible that you could be asked an exam question about the limitations of it. Right.
So no outliers and only linear.
Yep. So note. Actually, we don't need that anymore. So note. Pearson's.
It is a long note.
No.
A baby note.
There'd be 1, 2, 3, 6 or 7 lines on my bit of paper. But they include some dot points, which are not full lines. Pearson correlation coefficient. Works on the assumptions. First assumption, as I said, the data is numerical. Variables are numerical. This is the first one. Second one, the association is linear.
Does that work on the assumptions?
Yes, it does. You need glasses.
No, it's just his writing.
That's all right, Sam. I'm not precious bad. I know my writing's not the most neatest in the world.
Oh, me too, Mr. Sinnott, it's alright.
You know,
Yours is worse.
I've learnt to live with it.
I am precious.
And really, I must admit that when I was at primary school, I never actually got a pen licence.
Oh no.
Yeah, I just waited till the next year and started using a pen anyway. So,
That's like 10 sad stories.
And now there's one turns out story. There's no way wear colourful shirts.
I know.
and the last one was there's no outline, outliers. So if the data includes any of those things, then it could be misleading. Coefficient. Could be misleading. All right. So you notice that in this here, I've used, used the word could be misleading rather than will be misleading. So depending on how non-linear, how far away the outlier is, it may not be too bad, but you can't necessarily rely on it. And that kind of, when we're making statements, we need to make those kind of statements where, this could be this, could be that. There's an association, but there could be other stuff as well. So, all right. So that is it for scatterplots at the moment. Sorry?
Where do we find the R?
Right. We'll get to calculating the R next lesson. All right. So we'll do that next lesson. So for today, we'll just look at those two things. So exercises 3D and E. And then, Tuesday we'll look at how we calculate it. And don't forget, like and subscribe.